Okay, we are going to work on notes for section 10 for day 1. These are actually pretty easy notes. It's just a lot of vocabulary, and then when we meet again, we'll go over day 2 notes and work on common tangent problems. Okay, definition of a secant. A secant is a line that intersects a circle at exactly 2 points. Every secant contains a chord of the circle. So here is a secant. And it crosses at point A and point B, and your chord would be AB. Tangent. A tangent is a line that intersects a circle at exactly 1 point. The point is called the point of tangency or point of contact. So if we were to draw this, I'm going to do my best here to only touch the circle at 1 point. And then this would be the point where it touches, and that's the tangent. Tangent segment. A tangent segment is the part of the tangent between the point of contact and the point outside the circle. To draw this, we would go from the point that it touches the circle to another point outside. So we'd have a point here and the point of contact, and this would be the tangent segment. We can label this point P and point T. Secant segment. A secant segment is the part of the secant line that joins a point outside the circle to the farther intersection point of the secant and the circle. So to draw this, let's start outside the circle at a point, and we'll go through the circle to the farther intersection point. We can label this point P. Right here where it crosses the circle is G, and then over here will be R. So we can say that PR is the secant segment. PG is the external part of the secant segment. The external part of the secant segment. Next page. Tangent circles. Tangent circles are circles that intersect each other at exactly 1 point. We're going to have 2 types of tangent circles. We have externally tangent circles. So the external ones are right here, and you see that they only touch at 1 point. So their 2 circles are externally tangent if each of the tangent circles lies outside the other. Then internally tangent circles are going to be 2 circles are internally tangent if one of the tangent circles lies inside the other. So as you can see, we have 2 circles touching only at 1 point, and one is inside the other circle, so internally tangent. Next, we have common tangent. A common tangent is a line tangent to 2 circles. And again, we have 2 types. We have internal and external. So the common internal tangent is a tangent that's going to lie in between the 2 circles. So let me see how well I can do this. So it's a little tricky, but you want to get a line that is touching both of the circles. The line has to be in between the 2 circles, and you want it to be tangent, so really try to get it to only touch at 1 point. So that is a common internal tangent. A common external tangent is a little bit easier to draw. It is a tangent that is not between the 2 circles. So here we go. That would be your common external tangent. Last page. We have a couple postulates here. The first one says, a tangent line is perpendicular to the radius drawn at the point of contact. So if we have a tangent, if we're going to go from the center to the tangent line will be perpendicular to the radius drawn at the point of contact. The next postulate says that if a line is perpendicular to the radius at its outer endpoint, then it is tangent to the circle. So if we know that this line is perpendicular to the radius, so this line is perpendicular to the radius, then it is the tangent. All right, the theorem 85. If two tangent segments are drawn to a circle from an external point, then those segments are congruent. So let's get that external point situated right here, and we're going to draw two tangents from that point. So let's label these. We'll have point P here. It'll touch here at X, and it'll touch here at Y. These would be the tangent segments. So another tangent segment, okay? If two tangent segments are drawn to a circle from one exterior point, then those segments are congruent. So we can say that PX is congruent to PY. And that concludes your notes for day 1, lesson 10-4.